Oh, I get that gets late. Okay. So, maybe you got them all finished. If not, finish those questions for homework. Okay? Let's have a look at the next topic now. So we're having a look at something called degree 2 systems. Okay. Just, open something here for you. So these are problems that involve two lines. So what we care about in this lesson is finding where two lines cross. So for example, this is one line, this is another line, and they meet here, and we want to know what is this point. Okay, and this is called, well, does anyone know its name? Common point? Common point is fine, yeah, but it has a special name. Go on.
Intersection point.
Intersection, yeah. Intersection point. Where they meet. And this is what we want to find today. So in total, there are 4 methods we can use, but only 2 of them will be on the exam, or I mean are going to be asked in the exam. So the first method, so we'll say method 1, is to use a graph. Now this, use a graph. Now this is actually a bad way to do it. Why is it a bad way to do it?
Most of the time the graphs are not properly plotted, they're just sketched.
Yeah, I mean it's not accurate, it's not precise. But we'll do one as an example just to show you. So the first method is to use a graph. So for example, find the intersection point for this line and this line. So we want to know where do these meet. So we want to find the intersection. Right, so the first method is to use a graph. And this will be a very bad method, but we'll try our best. So we need 2 points to make the graph. So for the first line, if you make x is 0, what's y?
9.
9. So 0, 9. So that's the first point here. Now, for the next point, I'll just use x is 2, for example. So if x is 2, for example, let's say there's 1, there's 2. What would y be? If x is 2, what's y?
0.
Minus 1. So that would be like here, wouldn't it? So the line would look something like that. Something like that. Right, so for the first one, if x is 0, what's y? 2, yeah. And let's use 1, for example. So if x is 1, what's y?
Minus 4.
Minus 4, which would be like about here. So this is going to be a huge problem because it looks like the lines are parallel. Now they're not actually parallel. What's happening is they're probably going to meet up here. Yeah, so I don't know. Minus, let's have a wild guess. Minus 420. We'll see. Yeah. Now, to make this a little bit neater, I'll use a program to draw it just to show you. So y equals minus 5x plus 9. Y equals minus 6x plus 2. Let's graph the first one. We'll see. So they look like they're parallel, don't they? But if we zoom out a little bit more, okay. Could be -7. What do you think? -8?
Yeah.
Oh, I don't know actually. I'll have to do it properly. -7 and then, but not 20, more like 42 or something like that. So can you see why this is a bad way to do it? It's not going to work. So this method, don't use it for the exam. Okay. Let's actually get the exact answer here. So solve system. So -7 and 44 was the right answer. Okay. So yeah, we were a little bit off. So method 1, don't use this method. The real method would be the next one, method 2. But they sometimes ask you to draw these in the exam and to estimate the answer. So if they do make you use this method in the exam, the answer will always be a small number, you know, like something like 2 and 3, something easy to do. Okay. Right, method 2 now. Yes, this has a name. Substitution. Substitution method. This is one method, yeah. Okay. So if you can write this name down, substitution method. In the exam, they sometimes tell you which method to use in the question. So the question might say, use the substitution method to get the answer. Let me write down. We'll say, I don't know, yeah. Okay. Right, so if we can write this example down, and I'll show you what the substitution method is. Okay, so for the substitution method, your goal is to get y equals for one of them. Now in this example I made it a little bit easier for you because you already have what you want here. You have y as the subject. So what you do is, in the other equation, you replace the y with this, because this equals y. So in the first one, the y can be replaced by this. So you get 5x minus y, which is 2x minus 3 equals 0. So can you see, this is now the y. It's been substituted, it's been replaced. Now the problem is easier because there's only x here. 5x minus 2x plus 3 minus 3 equals 0. Yes? So 3x equals 0. So x equals 0. How can I get y?
We substitute.
Yeah, make x here, yeah. Put the x in, yeah. So you get now that y equals minus 3. So the answer is 0 minus 3. This is the substitution method. I'll do another example of this one. Okay, so if we can write this down, please.
Why is it plus 3?
Minus,
Oh,
minus.
oh, yeah.
Okay. Next example, I'll do another one like this. So, for example, y equals minus 7x minus 7, y equals minus 8x minus 4. Now, this one is equal to y, and this one is also equal to y. So if you replace the y here with this, you can get minus 8x minus 4 equals minus 7x minus 7. Can you see that? Yeah. So we have 8x minus 7x equals 7 minus 4 when you move them. X equals 3. And then we take this and put it back in, say, here, and we'll get y equals minus 8 times 3 minus 4, which is minus 28. So the answer is 3 minus 28. Yep. Okay, so write this one down. That's our second example of the substitution method. Okay. You have this one written down now? Okay. Next method. So method 3 is the most common method called elimination. Elimination method. The one you probably use in school back home. So let me show you how this method works. Let's have an example. 7x minus 8y equals 5, and 4x minus 3y equals 6. So for this method, you're trying to make x or y the same by multiplying each of them by a number. So if we make, for example, x the same, the way we can do that is by multiplying this one by 4 and this one by 7. So we'll get 28x minus 32y equals 20, and 28x minus 21y equals 42. So multiply 4, multiply 7, and then the next step in the method is to subtract. 28 minus 28 is 0. Minus 32 minus 21, what's that, minus 11. Minus 11y equals 20 minus 42 is minus 22. So what does y equal?
2.
2. 2, yeah. To get the x, put it back into, let's say, this one. So we get 4x minus 3 times 2 is 6 equals 6. So 4x equals 12. So what's x? 3. So the answer is 3, 2. Okay. This is probably how you did it in high school, yeah? Yeah. So if you can write this method down, and I have one more method to show you, which I'm sure will be new for maybe all of you. or middle school even. Yes. Okay. The last method to show you is not on the exam, but it's a useful method if you want to use it, and it's very useful for very difficult problems. Can I scroll down?
Yeah.
Yeah? Okay. Yes?
Yeah.
Yeah. Okay. This last method is a little bit tricky. Method 4. Gaussian. Does anybody know this method? You think you might? It's quite tricky. I'll show you the method with a simple example, and then I'll show you the method with a difficult example. So, a simple example first. 7x minus 8y equals 5. 4x minus 3y equals 6. So the first thing you do in this method is you write, to make it easier to write, you write the numbers in a block. So you write this problem as 7 minus 8 dot 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 5, 4 minus 3, 6. So you just write it in this block. And there's two rules when it comes to this block that you'll need to know. The first rule is you're allowed to multiply any row by any number except 0. So you can multiply any row by any non-zero number. That's the first thing. So you're allowed to multiply these by any number except 0. And the second rule is that you can add or subtract rows onto either row. Now I'll explain that in a moment with an example. So these are the two basic rules, and we'll have a look at it now. So let me just write it again here. 7, 4, minus 8, minus 3, dot, 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 5 and 6. Okay, can I start it now? Yeah? Right, so I'll do it, and then afterwards I'll explain the logic for why I did each step. So the first thing I'll do is I'll multiply this by 4 and this by 7. So I'll get 28 minus 32, 20. 28 minus 21, 42. Yeah. Then what I'll do is I'll do row 1 minus row 2. Of course, you know this means row, don't you? Yeah. So row 1 minus row 2, but then I need to choose where to put the answer. So I'll put the answer on row 2. So I keep the first row the same, and then row 1 minus row 2, put the answer on 2. So 28 minus 28, 0, minus 32, minus 11, minus 22. Okay. And then next thing, I'll multiply this by minus 1. Well, you know what, actually, let me just think here. I'll multiply this by 32 and this by 11. So I'll need a calculator if someone can hit that in. 28 times 11, please. 308. And then the next one with a minus, and then 220. 0 minus 352, and then the last one 704. Okay. And now what I'll do is I'll do row 1 minus row 2, and I'll put the answer this time on 1. Okay. So 308 minus 0, 308. This minus this,
Negative
0. 220 minus 704, maybe one.
584.
Are you sure?
Negative.
Negative.
Yeah, okay, yeah. Are you sure?
Yes, maybe.
Double check it.
No, 480.
Use the calculator, it'll make me feel better. What is it?
484.
Are you sure?
Yeah.
With a minus?
Yeah.
Okay, because if this answer's wrong now, right, and then this one here stays the same.
I think you missed a minus on 7.
Which row, where did I miss my minus?
704.
Oh, sorry, thank you. Oh, okay. Yeah, that's a minus,
Yes.
because I multiply it here. Yeah, thank you. Oh, so this is not 484 then?
That's 924.
924.
Uh-huh.
Okay. 924, and then 352 and minus 704. The second row is the same. So the last step, multiply this by 1 over 308, and multiply this by 1 over minus 352. Okay, so this will be 1, this will be 0, and this one here will be 3. And this, this is 3. This one here will be 0, this one here will be 1, and this one here will be 2.
Yes.
Let's rewrite the equation, because you remember what this block means. This means 1x plus, what's this one? 0y equals 3. And this one, what does it mean? 0x plus 1y equals 2. Or in other words, x equals
3, y equals 2.
Yeah. So when you have it in this form, like this, this is the x and the y.
Okay.
Yeah. Have you seen this method before?
Yes, but I remember we did something different, a different way.
Different way. But
I think it was.
there's a matrix method which is very similar, but not actually the same method as this.
It's not the same, no.
No.
It's similar.
Okay.
Do we have to memorize it?
No.
No.
You can delete this off your memory.
Well, I wouldn't delete it from your memory. But this method, it works really, really well for difficult ones. I mean, you probably don't want to use this method for 2, x and y. But this method works great when you have 3, like x, y, z. Okay? And the goal is to get 1, 0, 0, 1 here. But if you have 3,
It's 1, 0, 1.
yeah, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then you have x, y, z. Yeah. So we'll do one more example, but this time we'll have 3 in them. Okay. Can I do that one now? Yeah. Okay. That's not on the course anymore. It used to be, but it's not anymore. So sadly, no matrix method anymore. Okay. 2x plus y minus z equals 2. X plus y plus z equals 3. 3x plus y minus 3z equals 1 then. Okay, can you write this one down?
Should we write the first one?
No, it's okay. We can write this one down as an example then. I'll go a bit slower for this one. Okay. Now, there's one other rule that you can use So we have two rules so far. You can multiply any row by any non-zero number, and you can add or subtract any two rows and put the answer on either of the rows. There is a third rule which you don't usually need. It's pretty obvious though. You're allowed to swap any of the rows because it doesn't matter what the order is. You know, if I write this one first, this one second, and this one third, it's the same problem if you swap them around. Do you know what I mean? So it doesn't actually matter about the order of the rows. You can swap rows. It's no problem to swap. But that doesn't really help anything, usually, so we don't bother with that one. But you're allowed to do it. Okay, so we'll do this one together. Maybe we can figure out together what to do. And I'll remind you that your goal is to get ones and then zeros on the other side. Okay, so we have 2, 1, minus 1, 1, 1, 1, 3, 1, minus 3, dot, 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 2, 3, 1. Right. What could we do first?
We can start the second row.
Which row?
The first row.
We could. Doesn't help too much. No problem doing that, but maybe something else.
Start multiplying.
Start multiplying. Multiplying by what though?
3.
2.
Well, which row?
First row, 2.
First row with 3.
Yes.
And second row with 6.
Yes.
And third row with 2.
2. I think this is a good start because you can make all of these the same. Right, so write that down, and then the answer would be 6, 3, minus 3, 6, 6, 6, 18, 6,
2 minus 6.
2. Okay, so I'll just give you a minute to write that down, and then we'll decide on what the next step is.
Where did we get the 6 from?
It doesn't have to be 6. It's useful to make all these the same at the start.
Oh.
Now you'll see in a minute why, because when these are the same and I subtract, then I can start making zeros. Okay, so what should we do next?
We delete all the 6.
How though?
Subtract.
Yeah, so row 1 minus
row 2.
and put the answer,
3
or 3, yeah, and put the answer on
2.
2. And also,
Row 2.
Maybe. Row 1 minus row 3, put the answer on 3. Okay, so let's do this one carefully. So does row 1 change?
No.
No, because only 2 and 3 get changed. So I'll keep 1 the same. Right, so row 1 minus row 2, put the answer on 2. So 6 minus 6, 0. 3 minus 6, minus 3, minus 3 minus 6, minus 9. 6 minus 18, minus 12. And then row 1 minus row 3. So 6 minus 6, 0. 3 minus 2 is 1. Minus 3 minus 6, 3. And 6 minus 2, 4. So this is pretty good. We already have 0 and 0 here. Right. What's next now? You have two things you could do next. There's 2 choices.
Subtract immediately.
Which ones?
No, I think we have
Another multiply.
Multiply by -1.
Yeah, you have 2 choices. You can either multiply this by 3 to make these the same, or you can actually multiply this one by 1 over 3.
Oh.
I think I'll choose that one to make the numbers smaller.
1 over 3.
Yeah. So I'll multiply this one here by 1 over 3.
Not -1.
I don't need to worry about the minus or the plus because I'm allowed to add or subtract the rows.
Yeah.
So it doesn't matter too much about that. So I'll have 6, 3 minus 3, 6, 0 minus 1, minus 3, minus 4. And then the last one's the same.
Yeah.
What do I do next?
Plus
Yeah, row
1.
row 2 plus row 3 and put the answer on
rod 3.
3.
But why we didn't make it the same like before? Like
We are making we're making these two the same. I want to try and kill them.
Oh.
Yeah. So let's do that one. The first two are still the same.
0.
That and that. Okay, row 2 plus row 3. So 0, 0, 0, this and this,
0.
0, this and this.
0.
Minus 6.
Oh, no.
Oh, we're adding 0, 0.
0, isn't it?
Yeah, 0.
Oh, rats, I made a mistake in my question. That shouldn't have happened.
0.
Rats.
Because all 3 are the same number.
No, there's something worse than that.
Z is 0? Is that 0?
We
No.
can delete this and have a break.
Let's see. Rats.
Maybe we could.
Try eliminating the third.
No, my problem is when I made the question in my head, I didn't make it the right way. So I need to change something in the question to fix it. How about, okay, I'm sorry about this. We'll need to change, if you can make the changes in your notebook. I'll change this to a plus here, and this will become a 7. So this will be a plus 3 here, and this will be a 7. What changes here? This will be a, what happens here? This will be a plus,
Plus 6.
huh?
Plus 6.
Yeah, it becomes plus 6.
Oh yeah, okay, plus 6, sorry, plus 6, and this will become a 14. And then what changes here? What did I do with, how did I use row 3 for the last one? Row 1 minus row 3. So minus 3 minus 6, so this should be now minus 9.
Minus 18.
And then 6 minus 14 though, isn't it? 6 minus 14?
Minus 8.
Minus 8 here.
Minus 8.
Minus 8, okay. So this is still, so I can just fix that here. This is now going to be,
Minus 9 and minus 8.
yeah, that's all. This is what happens when you make questions up in your head. Right, minus 9 and then minus 8. Okay. That solves my problem down here. Right, so let's try that again. 0 and 0, 0. Minus 1 and 1, 0. Minus 3 and minus 9 is minus 12. Remember, we're adding here.
Oh.
Yeah, minus 12. And then minus 4 and minus 8. Minus 12. That's much better. It's a big problem if you get zeros on any row. That should not happen. If that happens, it means it's a mistake in the question. So it shouldn't happen. Now, you might think, oh, well, this is going to take forever because I'm only halfway finished. I only have zeros here, here, and here. What else do I need to make 0?
First row.
This one,
Yes.
this one, and this one. And then I need to make these 1s. But actually, if you can get it to this step, it's good enough. I'll show you why it's good enough now. If you can make a 0 here, here, and here, that's actually good enough. Because watch what happens now. Do you have this block? So, if I rewrite these equations, the first one is 6x plus 3y minus 3z equals 6. Next one is minus y plus 3z equals minus 4. And the last one?
Minus 12. Z equals
12.
Z is 12.
Z
Z
is 1.
is 1.
Try again?
Minus 1.
Minus 1, yeah.
No, it's
No, it's one.
Oh, there's a minus there, so sorry, it's 1,
One.
this one, yeah. Now, can you see why I'm saying this is good enough? Because
You know.
this gives me
1.
Z, yeah. If I know the Z, then I can know the Y. And if I know Z and Y, then I can know the X. So you can go, this answer goes here, and this answer goes here. So if you can at least get this, that's good enough. That's good enough. So, what's the Z?
Z is 1.
1. And if I put that in here,
And Y is 7.
let's see, Z is 1, so minus 4,
7.
minus 3, minus 7, is it?
Mm-hmm.
So Y is minus 7.
Y is 7.
No, 7, no,
Positive 7.
positive
Minus
7.
Y, so yes.
Yeah, it's minus Y is minus 7,
So Y is 7.
so 7 then. And then lastly the X, well if I put those numbers in there I can get the X.
X is minus 2.
21.
6X plus 21 minus 3 equals 6. 6X equals, what's that now? 18. 6 minus 18 minus 12.
Yeah.
Minus 12.
X is 2.
Minus 2.
Okay.
Minus 2.
Minus 2. Alright. So, this method, I know it seems long, but it's only long because I have to go slowly through it. If you actually look at the number of steps, it's not that many. Really?
1, 2, 3, 4, 5, 6, 7,
Yeah, but
8, 9, 10.
no.
You have to multiply each one, so that's 3 steps.
I know that doesn't count as 3 steps. This counts as 1 step. So first you did your multiplying to make the 6's here. Then you did some addition and subtraction to make zeros here. Then you did another multiply and another addition to make more zeros. And then I can stop now. I have enough zeros. This can be rewritten as this, which can give me the answer quickly. Okay. So this method, you really should only use it when you have 3 or more. So when you have 4, you can really see the benefit of this method. Okay. Because you let me think. If you think about it like this: multiply, add, and then you're done at this step. So I think of this as 1, 2, 3, 4, and then once you get here, you're happy.
But it would have more steps if it was 4, yeah?
Yeah, but not much more. So if it had 4 steps,
2 more.
if it had, yeah, it'd just be 2 more. So if it was W, X, Y, Z, the only difference is it'd be multiply, add, and you're done then. So it'd be an extra 2.
Are you going to ask us?
No. Well, no. For semester 1 exam, it'll probably only be 2. Yeah, 2 is what you'll have to worry about. So for the semester 1 exam, you don't need this method, but I wanted to show you this method because I think this is a new method for everybody.
Yes.
Yeah. Some people might have seen a method similar to this called matrix method. You know you have. Anyone else? You think you've seen the matrix method before? Yeah. It's kind of similar idea. Right, so your homework, which you can start now, is if you can do, we'll say, yeah, I'll write down here. 1A.
I have homework from the previous slide.
Oh, don't worry, I know that, yeah. So now you have 2 homeworks, one from the previous and one from the current. 1A, 2A, and then we'll have 3AB, and then 4A, and 4A is optional. You don't have to do it. I'd like you to do it, but you don't have to do it. So there, 1A, 2A, 3A and B, and then 4A. Okay, so you can start them now. I'll open them up on the screen here if you want. So, did you write those down? 1A, 2A, 3A, 3B, 4A.
Yeah.
Yeah, here we go. So in 1A, it's the graph method. Number 2, substitution. Number 3, elimination. And number 4, Gaussian. Okay. So 1A, 2A, 3A, 3B, and then 4A is optional. Zoom in. Yep. More? This is okay? So 1A is the first one here. Let me just